Hello everyone. I, Miss S.M. Jagta from Maratha Vidya Prasarak Samajas, KBT College of Engineering, Nasik, welcomes you on my today's session. And my today's session is on the study of the phase modulation. What are the learning objectives? We will understand the concept of phase modulation. We will learn the difference between the frequency modulation and the phase modulation. And we understand the concept how to find out the index and the deviation ratio, and we will understand what is the relationship between the frequency modulation and the phase modulation. We will compare amplitude modulation, frequency modulation and phase modulation. Now let us understand or revise some points regarding the modulation first. Modulation is a process by which certain parameter of sine wave, that are the certain parameter of sine wave means amplitude, frequency and phase. Certain parameter of sine wave is varied in proportion with instantaneous value of modulating signal. Again, the modulation is of two types, amplitude modulation and the angle modulation. Whereas the amplitude modulation is the amplitude variation by keeping the frequency and the phase constant. And as we discussed earlier, in case of angle modulation, the frequency is going to be varied in case of frequency modulation. And now in today's session, we are focusing on how the modulation is done with respect to the phases. In frequency modulation, the frequency of the carrier wave varies, whereas in phase modulation, the phase of the carrier signal is varies in accordance with instantaneous amplitude of the modulating signal. So, in phase modulation, the amplitude and the frequency of the carrier remains constant, and as you observe, the phases is going to be varied. The phase of the carrier signal is varied according to the instantaneous amplitude of the modulating signal. This represents here that the phase modulator has an input, one should be the modulating signal, and second is a carrier. And by modulating this with the help of phase modulator, we got a signal like a phase, phase variations. This is called as a phase modulation. Now we will understand the waveform of it. This is a baseband signal which has a specific amplitude of AM. It may be EM, it may be VM with respect to the time t. We have a second and the most important signal, that is a carrier, represented by AC, represented by VC or represented by EC, varies with respect to the time t. And after multiplication or the phase modulator, these two signals are perform the operation, and we got a waveform like a phase modulated waveform here. Sometimes the phases is going to be work as a positive, whereas sometimes the phases are going to be work as a negative. What we observe here, the amplitude of the waveform remains constant, that is a phase modulated signal. Amplitude remains constant, but the phases are going to be varies. It is the process in which the phase of the carrier is changed in accordance with the amplitude of modulating signal, keeping its frequency and amplitude constant. Phase shift of the carrier carries the information in this type of modulation. And we know that the FM and PM are strongly related with each other. This waveforms is again represent the signaling of frequency modulated signal, where we got a deviation which is in terms of maximum deviation, whereas in case of PM signal, look at this waveform, this is maximum deviation towards the negative cycle, whereas towards the positive and negative we got a maximum deviation in frequency modulation. One of the signal is required unmodulated carrier, whereas this signal is a modulating signal. Now we know that the frequency modulation and the phase modulation are strongly related with each other. A single tone phase modulation is the type of phase modulation in which the modulating signal is a single frequency sine wave. Yes, as the modulating signal goes positive, the amount of the phase lag increases with the amplitude of modulating signal. When the modulating signal goes negative, the phase shift becomes leading. This causes the carrier wave to be effectively compressed. The PM wave is obtained by varying the phase angle phi of a carrier in proportion with the amplitude of the modulating voltage. Yes, we know that the carrier voltage is always expressed by EC A sin omega ct plus phi, whereas the EPM, that is, the EPM is related with the phase modulation. EPM is represented as A sin omega ct plus phi m sin omega mt, whereas the termination of the term phi m is a maximum phase. Now come towards some mathematical representation in case of phase modulation. The phase of the modulated wave got infinite points, whereas phase shift in a wave takes place. The instantaneous value of amplitude of modulating signal is changes the phase of the carrier signal. When the amplitude is positive, phase changes in one direction, and if the amplitude is negative, phase changes in opposite direction. Whereas the equation of instantaneous phi I in phase modulation is represented by Kp m of t, where Kp is a phase sensitivity and m of t is a masses signal. Yes, this is the standard equation of angle modulated wave. Yes, it is S of t is equal to Ec cos 2 pi fct plus phi I. S of t is equal to Ec cos 2 pi fct. We will place the value of phi of t from the previous equation. It is Kp m of t. And this is the equation of phase modulation. And we know the value of modulating signal is m of t is equal to Em cos 2 pi fmt. So, S of t is equal to Ec cos 2 pi fct. We will place the value of m of t in the equation. Em cos 2 pi fmt. Then, it should be replaced by beta cos 2 pi fmt. Whereas beta is a modulation index represented by del phi. Del phi is equal to kpam. Del phi is a phase deviation. Basically, the phase modulation is used in mobile communication system, while as the frequency modulation is used mainly in FM broadcasting. Now, this represents the relationship between the frequency modulation and the phase modulation. Just now we understand the concept of the Kp factor. Kp is equal to phi by Em. We know that Kp is a proportionality constant, whereas phi is a phase deviation in radians, whereas Em is Em sin omega mt. So, from all the equations we got a value of Pm is equal to A sin omega ct plus Mp sin omega mt. The bandwidth of the Pm is Bpm is equal to 2 del plus Fm. Frequency is the rate of change of phase, means that frequency is the derivative of phase. If the frequency is increases, phase also changes rapidly. Looking by this total waveform, we will understand this how the frequency modulation and the phase modulations are closely related to each other. The frequency is the rate of change of phase, means that frequency is nothing but the derivative of phase. If the frequency increases, phase also changes more rapidly. Once the frequency decreases, phase angle starts to lag behind the carrier phase signal. Let us now see the difference between the FM and PM. We have seen that the PM basically is uses to produce the frequency modulation. FM is produced by PM if and only if the phase shift is being varied by referring above waveform. For, for frequency modulation signal, the carrier frequency is changes with change in instantaneous modulating signal value. It remains constant during the interval T2 at this maximum value. During T5 interval, its value is minimum. Observe here. This is the interval T2, yes, whereas this is the interval T5. Now look at the phase modulation waveform. The frequency of the phase modulation wave changes only and only if amplitude of the modulating signal changes. But during the interval T1, T3, T4, T6, the frequency of the phase modulated wave changes. Observe here T1, T3, T4, T6. But during the interval T2 and T5, when the modulating signal is constant, the frequency of phase modulated signal remains constant at the carrier frequency value with some phase shift. For PM, for phase modulation, at the peak amplitude points of the modulating signal, the maximum phase deviations takes place, whereas in FM, the frequency deviation is proportional only to the amplitude variation of the modulating signal, and it is independent of the modulating frequency FM. Whereas in phase modulation, the frequency deviation increases with increase in modulating frequency FM and decrease with decrease in modulating frequency FM. This is about the relationship between the phase modulation and the frequency modulation. Now we will compare the all modulation techniques here. Yes. What happens in case of amplitude modulation? The variable parameter is amplitude, whereas in FM and PM the variation parameter is frequency and phase. Which parameter remains constant? The amplitude remains going to be changes, that is amplitude varies. Yes, amplitude remains constant in phase and frequency. The bandwidth in case of amplitude modulation is a constant, it's twice FM. Whereas in case of frequency modulation, it should be depend on a content of del, that is a deviation factor. Del plus modulating frequency. It is 2 del plus W. What is the noise immunity? Noise immunity is very poor in amplitude modulation, whereas it's better in frequency modulation. Whereas in phase modulation, the noise immunity is better than amplitude modulation, but worse than the frequency modulation. What is modulation index? In amplitude modulation, it should be less than unity, whereas it should be more than unity for wideband FM in frequency modulation. The number of sidebands are preferred in amplitude modulation is 2, whereas the number of sidebands present in frequency modulation is infinite. The design complexity is there Yes, in case of amplitude modulation, the circuit complexity or the design is very simple, whereas in FM and PM, it should be very complex. Efficiency. Lower efficiency is preferred in case of amplitude modulation, whereas the efficiency is better in FM and PM. Where we are using amplitude modulation, in radio broadcasting, we are definitely preferring amplitude modulation, whereas in sound system, TV sound system, radio, we are preferring a frequency modulation. And the phase modulation is used in all the digital data communication systems. Yes, I hope you understand the details of phase modulation and the comparison point of the AM, FM and PM. Thank you so much everyone.